Hi, today I will talk about the second part of the questionnaire and about the model questions. So, first of it is the time about if I failed and what I learned from it. Failures come in life, I can say often. So, what we learned from it is one failure came is when I failed to meet a project delivery. And it causes a lot of problems in the project perspective as well as in the personal field, in professional field. And to learn from it means is to learn how to overcome those problems, how to get in that damage control mode and repair the problem for now, for then, so that it does not cause further problems to the professional as well as the personal front. And learning from it about the mistakes which made and trying to change it, trying to be a more systematic, more analytical, and judging by the ability where does it got went wrong. So in life you have to judge it sometimes where it went wrong, so that you can better prepare for it and come back strong next time. And so that's it. You have to learn from failures. And I learned about the more about the subject matter, more about the technology, and also this project, this failure enabled me to go more deep into whatever I was doing. And for that, going into the deep also helped me personally and professionally at the end, to be able to deliver more excellent, to be able to deliver more better in the next projects. Yeah, prior experience is data analytics. That is very important, but I don't have any prior experience in data analytics as such. But with the passion I have for it and the knowledge, the theoretical knowledge I have, I think I can match someone who have worked in data analytics with the theoretical knowledge. But for the practical knowledge, I can make it out with my desire for learning new things, with my ability to grasp things and ability to learn new things, and also by giving time and working dedicatedly in a project. Because after all, data analytics also it requires some special type of thinking, which is also a bit common to the overall IT industry. But and also after this course I'm better equipped to handle with the data analytics problems. And so I can, with a few months of training in the specific industry in the company, I can be able to match the experienced guys as well. I think that. So actually, I am not an expert in data analytics in practical field as I have no prior experience in it. Also, I am not a fresher as I have worked of almost 4 years in this IT industry, and so I know the industry landscape better than a fresher. I have some experience in how it works and in this industry and how is the going right now about the trends, the dynamics, and what it needs from an individual to survive and to bring and new ideas which are needed for the for this industry and its evolving change and fast changing landscape. So as I worked in a different technologies which also involved some database knowledge and that application knowledges, I am better equipped than a fresher to handle the newer challenge and the bigger challenge of data analytics. And I also know I have a practical experience about how it works in this field. So I think I can help over a exact graduate person by bringing in my IT experience in other fields. Though I'm starting new in data analytics, but it will be helpful. The knowledge from the other fields will be helpful in moving forward in this field of data analytics. Yes, what will happen is as these jars are mislabeled, suppose I pick from the jar which is labeled as apple and oranges and I got apple from it. That means that jar should be apple as it is incorrectly labeled, because it is labeled as apple and oranges and I got apple from it and I know it is incorrectly labeled, so that must be apple. Okay, and so it must be apple, and so now the jar which is labeled oranges has to be mixed, as it cannot be the oranges jar as they are wrongly labeled, and so if I go by this theory, the jar which labeled has apple has to be oranges. So if I proceed the other way around, if I take orange from the jar which is labeled as apple and oranges, so ultimately going in this way I can be able to figure that the three jars are as labeled, because all the labelings are wrong, as we have assumed that all the labelings are wrong. So by picking just one fruit from the jar which is labeled as apple and orange mixture, I will be able to solve the problem. So this all comes on assuming that all jars are incorrectly labeled, and so by picking only one fruit from the jar which is named as apple and orange, I can be able to distinguish between the all three jars and what they contains. Some data analysis tools which I worked on, it will include Excel, it will include R, and it will include Tableau. Though R is not a language, is not a tool, it is basically a language for carrying data analysis. And so the other tools are Excel and Tableau. Also we have done Tableau in a data analytics tool which helped in data visualization mainly. So it helps in producing good plots and graphs and bar charts, histograms with respect to the data which we have, and showing it to the business client for further results. So Tableau is a very good data interface tool which we can be used. And we have Excel, and we have Excel also is a data analysis tool for primitive type of data analysis. When the data size is not very large, we can use Excel over R, because Excel is easy, is more accessible to users, and also it provides some inbuilt functions which is more user friendly and easy to use in compared to R, where we don't need much coding and all. But Excel fails when the data size is huge, and so it is not very suitable for large data analysis. Also for other languages as such, I worked with other tools as such, I worked with Hue on AWS platform. So Hue is like an SQL on AWS platform which helps in data analysis in the AWS platform. Also I worked on Spark in the AWS platform, and Hadoop as well. I have the basic concepts of Hadoop, Spark and Hue. And coming back is SQL is the tool which contains the large amount of data, so it can be used in any data analysis to retrieve the data from SQL and convert the analysis on it, so that as it is the main storage of data, so from there we can be able to do our analytics and capture insights from it. So and then comes R is not a tool, it is a programming language actually, but R is one of the most statistically suited language, and it contains many statistical functions which makes it easy for data analysis, and also which makes it suitable for data analysis. So those inbuilt functions are the best feature in R. Also it is open source, and so it requires no cost to buy an R, and so it is useful in most data analysis problems. Other tools, actually it is better to have false negatives and false positives. In this case it is better to have false negatives, because for our case it is actually the positives which matter. So if we have a problem, we look at the problem, the inference is the sensitivity, which is the most important thing. It depends on the false positive actually. it depends on the positives, actually not false, it depends on the positives. So what happened is, let us take an example. We want to calculate the churn of a telecom company. So what we are interested in, we are interested in predicting the number of persons who will churn. So in this case our positive is the number of persons who will churn. So if false positives means it is causes the decrease in the sensitivity, which means that our model is not able to predict the number of persons who will churn correctly. So that is actually called as false positive. So actually what happens in this case is, it is predicting the person who is churning as a person who is not churned. So that is causing that model is failing to determine our aim, which is to find the persons, the probability of persons, and to identify the persons who will churn. So as this model fails in determining the persons who will churn, so it is becoming actually these persons who have churned but our model has predicted them as not churned, they are becoming as false positives. So it is harmful for our model. Better is false negatives. False negatives means a person whom the model is predicting as a churn but actually he didn't churn. So as a result of this, it causes some decrease in our specificity, and also it causes a decrease in our accuracy, but it is of less interest to us. Okay, so only we are on the positive side. So whatever our model predicts, in the finally, if we have too many false negatives, the model prediction will be worse than the original. So that means in the final situation, the model will hold true, as whatever he has predicted finally happens. Whatever has happened, that is better than it. So it is better to have false negatives. Like you can predict a person who will not churn, who has not churned, as a churn. But if you predict a person who has churned as not churned, that means it is a false positive, and so it is deviating our model to, it is reducing the accuracy of our model, and also it is causing the model to deviate from its main aim. So that means that false positive is worse than false negatives, and it is better to have false negatives in our model than to have false positives in it. But actually what happens is, too many false positives and negatives is not good as well. So we have to try to reduce the number of false positives and false negatives, but at least having some false negatives is better than having too many false positives. SVM is mainly used in machine learning theorems, where we got to know about numeric data, where we have numeric data and we need to build a separator. Okay, we need to build a separator between those dimensions. Okay, so what we actually conclude is that we have a separator which is determined by the SVM, by the by the classifier, and if the value is above the separator, then it falls in one category, and if it is below the separator, it falls in another category. Okay, so SVM helps in determining the number of categories in which the model will fall, depending on some on some marginal classifier value. Okay, so when we want some problems like data recognition, like digit recognition or letter recognition or voice recognition, so voice recognition, not like letter recognition or digit recognition, that time we use the SVM. So SVM is better than random forest, and random forest when we have some like some algorithmic approach, like yes or no, when we have two variables in that. Okay, so when the variables have two approach, and we can derive it like a flow chart, like a decision, that if it happens this, then do this, if it happens that, do that. So like this type of flow, if it is there, then we use random trees. So random forest trees is used for mainly decision making approach, which normally is a classification problem. Okay, which is normally is like a binary problem, like it has two values, one or two, like that. But SVM is used to distinguish between numeric values, like if we have some pixels. Okay, those pixels denote some number, we can use SVM to denote, to correctly predict what is the value of pixels for which number. So SVM is mainly used for classification, when it is a continuous variable with some pixel values and all, and random forest is used for classification when it contains of an algorithmic structure, like if you want to do it, do that, and like that. So if and else nested conditions can be best represented by random forests, whereas continuous type of separations between two variables, okay, between the class of values which falls in one class and in another class, the constant separation between them is better denoted by SVM. My favorite machine learning algorithmic has by far been logistic regression, and which I have found most suitable and most beautiful and naive to use. Also, it gives classification based on the it's a linear method actually, and gives a yes or no classification, like a 1 or 0 probability type of classification based on the dependent variable based on the independent variables. And also it can help determine the factors, the independent variables on which the dependent variable value depends. So logistic regression is used in cases where we have two values for a dependent variable, like a probability if it is yes or no, and there is no concrete boundary difference between those two values. So in this case we have to use logistic regression, which is denoted by a exponential function, the exponential curve, to differentiate between the positive and the negative values of between the true and the false values of the dependent variable. So in this case we use logistic regression. Also logistic regression gives us good approach, it's a good method actually to determine those things. And also it gives some relative counts with gain, lift, and case statistic. It gives us the approach how to overcome the problem also, like you how to search in which decile so the problem is solved, and like that. So logistic regression is also a part of the is also a part of this supervised learning, wherein we have some data, and based on that data we are able to predict any new value of data and how it behaves on the new value of data. So I like that process very much. And my favorite machine learning algorithm, which I found it most subtle and most easy to understand, and also most applicable, and we can solve a lot of problems with it in our life, is logistic regression. How many footballs can you fit in a Tata Nano? This is actually a difficult question. How many footballs to fit? So actually the problem is the data is not clear. How many footballs means, first we have to know what football is they talking about. It is about the inflated footballs which is full of air, or is it the deflated footballs which is only that portion of the rubber portion of the ball without air in it. So this varies about the number of this varies about the amount of air which it has. Okay, so also it depends on the nano car. Okay, which nano car it depends on, if it is then which model. Okay, and what is the difference between the carrying capacity of each models, and what is the space excuse me, and what is the space which is occupied by the portion by the nano car, and how many. So it will vary according to the model, and it will vary according to the inflation of the football, whether air is inside the football. If air is inside the football, there can be less footballs which can be fitted inside the Tata Nano, whereas there it is full of air, then less, and whereas it is deflated, there is no air in it, then there can be more number of footballs which can be fit in that Tata Nano. So the next question is, what do we have uh, what are the type 1 and type 2 errors? Okay, so coming back to our nano part, we can calculate the volume of the total car of the nano, okay, which is the length by breadth into height. Okay, and we can calculate the volume of the football, Okay, so if we assume that the football is filled with air, we can calculate the volume by 4 by 3 pi r cube, which gives us the volume of the football. Assuming that all footballs have the same radius, so we can get volume of one football. And so if we divide the total volume of car divided by the volume of one football, we can get the number of footballs which can be fitted in that Tata Nano. Type 1 error means it is related to that hypothesis testing type 1 and type 2 errors. Type 1 error means when you fail to reject null hypothesis, though it is actually, you should reject it, though it is actually wrong. Okay, so failure to reject the wrong null hypothesis is actually type 1 error, and you accepted the null hypothesis though it is actually wrong. So you accepted the alternate hypothesis though the alternate hypothesis was wrong, the null hypothesis was correct. So that is actually the type 2 error. So what happens in type 1 error is you fail to reject the null hypothesis, and so thus you fail to accept the alternate hypothesis though you know that the null hypothesis is wrong. Okay, and in type 2 error you reject the null hypothesis and you accept the alternate hypothesis though you know that the null hypothesis was correct and the alternate hypothesis is actually wrong. So these errors, the type 1 error lies in the first quadrant and the type 2 error lies in the third quadrant if we plot the graphs like that. And so these errors must be looked into, and they are looking at and these are the problems of hypothesis testing which we should take care of. Bye, thank you.